Artificial intelligence appears simple from the outside. A user asks a question, an answer appears in seconds. But behind every response is a growing network of physical infrastructure under increasing pressure. Most people see software. Few see the systems supporting it. Every AI query depends on data centers, electrical grids, cooling systems, water treatment facilities, transmission networks, construction projects, and local communities. As AI adoption accelerates, demand for these supporting systems is rising at unprecedented rates. This is the story behind Meta's nuclear power strategy. The real question is not whether AI will continue growing. The question is whether the infrastructure supporting AI can keep pace. To understand why some of the world's largest technology companies are pursuing nuclear power, we first need to investigate the hidden stress points emerging throughout the system. Every AI response begins inside a data center. Servers process information continuously. Those servers require electricity. Electricity creates heat. Heat must be removed through cooling systems. Cooling systems require water. Water must be collected, treated, purified, distributed, and managed. The chain extends even further. Power plants generate electricity. Transmission networks move it across long distances. Substations transform voltage levels. Water treatment plants provide cooling resources. Construction companies build the facilities. Communities provide the land and infrastructure. An AI response may appear digital, but the process behind it is deeply physical. The more AI grows, the more pressure is placed on every link in this chain. The challenge facing the industry is no longer just computing. The challenge is whether the supporting infrastructure can expand quickly enough to support the next generation of AI systems. The modern AI data center is one of the most power-intensive facilities ever constructed. Thousands of servers operate simultaneously, processing enormous volumes of data every second. These facilities run 24 hours a day, 7 days a week. Unlike traditional office buildings, they cannot simply shut down at night. Every server consumes electricity. Every watt consumed becomes heat. Every unit of heat must be removed to maintain reliable operation. This creates a continuous cycle. Electricity enters the facility. Computing takes place. Heat is generated. Cooling systems remove that heat. The process repeats every second of every day. As AI models become larger and more complex, computing requirements continue to increase. More computing requires more servers. More servers require more power. More power creates more heat. More heat requires more cooling. The result is a system whose growth increasingly depends on infrastructure rather than software alone. Cooling has become one of the most important challenges facing modern AI infrastructure. Large data centers generate enormous quantities of heat. To remove that heat efficiently, operators often rely on sophisticated cooling systems supported by extensive water infrastructure. Before water reaches a data center, it must pass through multiple stages. Water is collected from rivers, reservoirs, or municipal systems. Treatment facilities remove contaminants. Purification systems produce high-quality water suitable for industrial cooling applications. Once inside the facility, the water helps transfer heat away from computing equipment. After completing its role, it must be treated and managed before returning to the environment. As AI infrastructure expands, competition for water resources may intensify in some regions. This creates a new stress point. The future of AI may depend not only on computing power, but also on access to reliable water systems capable of supporting large-scale cooling operations. Power is becoming the primary constraint on AI expansion. Large AI campuses require extraordinary amounts of electricity. Some facilities consume power at levels comparable to major industrial operations. Supplying that electricity requires more than generation capacity. It requires transmission lines, substations, transformers, switchyards, and distribution infrastructure capable of delivering power continuously. The problem is timing. AI demand can increase rapidly, grid infrastructure cannot. Transmission projects often require years of planning, permitting, engineering, financing, and construction. Substations take time to build. Transformers face long manufacturing lead times. Utility upgrades cannot occur overnight. As AI development accelerates, electrical infrastructure is being pushed harder than ever before. This growing pressure on the grid is one of the key reasons technology companies are seeking new approaches to securing reliable electricity. Renewable energy plays an increasingly important role in modern electricity systems. Solar farms and wind projects continue expanding across the world. They provide clean electricity and help reduce emissions. However, AI introduces a unique requirement. AI operates continuously. Data centers require electricity every hour of every day. Computing demand does not disappear when the sun sets. It does not pause when wind speeds decline. Renewable generation fluctuates with weather conditions and time of day. Batteries can help bridge short-term gaps, but supporting large AI facilities continuously requires enormous amounts of stored energy. The challenge is not simply generating electricity. The challenge is delivering reliable electricity every second of every day. As AI demand rises, reliability becomes increasingly valuable. This reality is pushing technology companies to evaluate additional sources of firm power capable of supporting uninterrupted operations. Nuclear power addresses one of the most important requirements of AI infrastructure: reliability. Unlike weather-dependent generation sources, nuclear plants can operate continuously while producing large quantities of electricity. For AI operators, this consistency is extremely attractive. Data centers do not benefit from intermittent power. They require stable electricity around the clock. Every interruption creates operational risk. Every shortage limits future expansion. Nuclear power offers a potential solution to this challenge by providing dependable baseload electricity, capable of supporting long-term growth. The discussion is therefore shifting. The question is no longer simply how much electricity can be generated. The question is how reliable that electricity will be as AI infrastructure continues expanding. Meta's interest in nuclear power is fundamentally an infrastructure decision. As AI demand increases, access to reliable electricity becomes a strategic asset. Meta understands that future AI growth depends on securing long-term energy supplies capable of supporting large-scale data center operations. The company is not merely purchasing electricity. It is securing infrastructure capacity for future expansion. The decision reflects a broader industry trend. Technology companies increasingly recognize that AI competitiveness will depend not only on algorithms and computing hardware, but also on access to energy infrastructure. Power availability is becoming a strategic resource. Meta's move signals that the next phase of AI development may be shaped as much by infrastructure planning as by software innovation. A new competition is emerging. Technology companies are no longer competing only for computing power. They're competing for access to infrastructure. Electricity generation, transmission capacity, water resources, industrial construction, permitting approvals, strategic land locations. All of these factors influence where future AI facilities can be built and how quickly they can expand. Unlike software, infrastructure cannot scale instantly. Building new power plants takes years. Expanding transmission networks takes years. Constructing industrial facilities takes years. As AI demand continues growing, the ability to secure infrastructure may become a defining competitive advantage. The next phase of technological leadership may depend not only on innovation, but also on execution in the physical world. This is the central question behind the entire story. AI demand is accelerating rapidly. Can power systems expand fast enough? Can water infrastructure expand fast enough? Can transmission networks expand fast enough? Can construction projects expand fast enough? Can permitting processes move fast enough? Can communities absorb the scale of development being proposed? Every part of the system is now being tested simultaneously. The challenge is no longer limited to software or computing capability. The challenge is whether civilization can build the supporting infrastructure required to sustain AI growth. The future of AI may depend less on what engineers can design and more on what society can build. Meta's nuclear strategy is not really a nuclear story. It is an infrastructure story. The deeper we investigated, the clearer the pattern became. AI depends on data centers. Data centers depend on cooling. Cooling depends on water. Water depends on infrastructure. Infrastructure depends on power. Power depends on generation systems capable of operating at unprecedented scale. Every technology eventually leads back to hidden systems. At Renea Energy, we investigate those systems. We follow the machines, networks, facilities, and infrastructure that make modern civilization possible. Because understanding the future requires understanding the systems that power it. Follow the system, understand the world.